So I need a little bit of help. If you look at example 3 right here, it says factor completely 16x to the 4th minus 256 and 3y to the 7th minus 15y to the 5th plus 18y cubed. My question to you is, what's the first step in any good factoring problem? We talked about this within the context of your last checkup. Math. Take out a GCF. Very good. So in part A right there, I do see a GCF. Do you? Izzy. It is 16. Nicely done. So you're going to take that 16 out of the problem, essentially doing the distributive property in reverse. And then you have to ask yourself, well, hey, 16 times what gets you 16x to the 4th? And that would be x to the 4th. So 16 times x to the 4th gets you back to 16x to the 4th. You want to bring down your minus sign, and then you have to ask yourself, well, hey, 16 times what gets you back to 256? Good, Calvin? Yes, very good. This is just a difference of 2 perfect squares in disguise. I know that, well, hey, because 16 is just 4 squared, and x to the 4th is x squared squared. So I'm just going to use my square root method, more or less, to help me figure out how I could then factor this yet again. So the 16 is still outside of a set of parentheses. And essentially when we factor, we populate 2 binomials. So if I want to figure out what numbers go in these binomials, just to review with you, if I want to factor essentially this difference of 2 perfect squares, all I have to do is think to myself, well, what 2 things can I multiply together to give me x to the 4th? And the answer to that is just x squared times itself. So x squared times x squared will get me back to x to the 4th. And then what, things could I multiply together to give me, 16 that'll eventually, cancel with the outers and the inners? Well, the square root of 16 is just 4. So this should be 4 and 4. And then if I want my outers and inners to go away, what's up, Eric? Yes. But you'll see the big idea in this chapter, the big question you have to ask yourself in this chapter, as opposed to chapter 4, is, can I keep going? Can I factor again? And what do you have to say there, Calvin? Yes. What do you see that factors again? Right. Well, watch out. X squared plus 4 does not factor. X squared minus 4 factors. We can factor a difference of 2 squares. We cannot factor a sum. You want to see why? Okay. So here's a little spatial reasoning for you. You ready? X squared plus 4. We'll throw back to chapter 4. X squared plus 4 is basically a parabola that's moved up 4 units on the y-axis. Its y-intercept is positive 4. Essentially, when we factor, we find x-intercepts. That parabola doesn't cross the x-axis, so it doesn't factor. However, x squared minus 4, on the contrary, is just a parabola that's moved down 4 spaces. Because it's moved down 4 spaces on my y-axis, I can see that this parabola indeed does cross the x-axis in 2 spots, 2 and negative 2. So it's for this reason that x squared minus 4 indeed does factor, while x squared plus 4 does not. X squared plus 4 actually has imaginary solutions if you were going to set it equal to 0. So it's this guy here that indeed does factor again. So we have to go one more time. We have 16. X squared plus 4 we just decided doesn't factor, doesn't cross the x-axis. And x squared minus 4 does. Heather. Not with cubes, right? So if it's squares, then what you're saying is true. If it's cubes, then what you're saying is false. You can factor a sum of cubes and a difference of cubes based on yesterday. You'll see in a little bit, I don't know how much you looked at this, Heather, but we're going to do that flow chart at the end of class today, that gold paper you got yesterday. And when you have things that are two terms, basically you're going to use one of these three methods. It's going to be a difference of two squares, a difference of two cubes, or sum of two cubes. So after you take out a GCF, if it's not one of these types, it can't be factored. Okay? Good question, Heather. So x squared minus 4, not done yet. We still have to factor that. That is, again, a difference of two perfect squares. So you could square root method that guy. And this will give us x plus 2, x minus 2. Now that guy right there is completely factored. I can't take out any other factors besides 1 or negative 1. That makes x squared plus 4, x plus 2, and x minus 2. Those are what we refer to as prime polynomials from yesterday's lesson. So I've written my answer as a product of prime polynomials, and therefore it is completely factored. Questions about part A? Okay, part B. The first step in any good factoring problem is to do what? Yeah, I hear it all around, GCF. I want to try to take out a greatest common factor. I do see one. Do you? Izzy? Yeah. So I could take out a 3y cubed, essentially doing my distributive property backwards. So 3y to the third power times y to the fourth power will get you back to 3y to the seventh. This is your product of powers property from the beginning of the chapter. 3 plus 4 is 7, so that's kind of why that is. Bring down your minus, and then we have 3y to the third times what gets you 15y to the fifth. Well, I need a 5 to get me back to 15 because the product of 3 and 5 is 15. And then I actually need 2 more y's to get me back to y to the fifth. Again, you're kind of subtracting, not multiplying. And then we have 3y cubed times 6 will get me back to 18y cubed. Now I have a trinomial. Basically, I would think most of you last night when you were working on these problems would use AC grouping. My period 1 really likes to use a shortcut that I kind of showed them. I think I may have shown it to this class, but I don't see anybody really like taking it and running with it. So I am going to show you a little bit of a shortcut besides AC grouping because I know some of you are sick of it. So this is how the big kids factor, like in the trig pre-calc classes and your calculus classes. They kind of don't really do the AC grouping method. Well, one, because they factor a ton, and two, it would take forever to do that grouping all the time. So here's a little bit of a shortcut. If it works for you, I would totally use it. But you can use AC grouping still, of course. I'm going to look at 6. And I'm going to think of, and in this case I'm allowed to do this. I should probably have prefaced my comments a little bit. Essentially what I am thinking about is, you know, there's a 1 in front of this y to the fourth here that doesn't really have a big effect on the problem. Well, hey, because it's 1. In this case, because this coefficient of y to the fourth is 1, I can do this shortcut. The shortcut changes a little bit if there's a different number in front of y to the fourth. So again, I'm using the shortcut because there's no number in front of this y to the fourth. See the 6 right here? I'm just going to think of the numbers that multiply to give me positive 6 that add to negative 5. The numbers that multiply to give me positive 6 that add to negative 5 are negative 3 and negative 2. I'm going to bring down my 3y cubed here. Negative 3 times negative 2 is positive 6. Negative 3 plus negative 2 is negative 5. And now what I'm going to do is I'm going to look at y to the fourth. If I need to multiply two things together to get y to the fourth, but when I combine my negative 3 and my negative 2, I get negative 5y squared, those things have to be y squareds. So if I look at this now, if I, foiled it real quick in my head, just checking my outers and my inners, I'd have negative 2y squared and negative 3y squared coming together to give me my negative 5y squared. I call this shortcut, I do have a little name for it, I call it unfoiling. When I learned it, they called it guess and check. Because I just guessed two factors and checked them. I checked the outers and the inners to make sure that they made negative 5y squared. This is going to be a shortcut I use quite a bit. It's best to use, you know, when there's no number in front of your y to the fourth or your y squared. Questions about that little shortcut? Okay, so now I have to ask myself, can I factor that any further? So I'm looking at y squared minus 3 and y squared minus 2, namely, and I'm going to ask myself, is that a difference of two squares? Is that a difference of two cubes? Thank you. Is that a sum of two cubes? And the answer is no. So because it's not one of those three types of things that we talked about in that flow chart a few seconds ago, you're done. The end. So this is actually our unfoiled, factored response. You can use that shortcut on your assignment for tonight. Whew. TMI. Okay, here's the 3 steps for the next problem. I'm going to have you copy those down while I sign Jared's pass here. Maybe. So step 1 in the problem that we're about to do is to get one side equal to 0. Where did your pass go? Step 1, we're going to set one side equal to 0. Step 2, you're going to factor the polynomial that's on the left side completely. And step 3, you're going to use the zero product property to solve. So in the last step, we use our zero product property to solve. Now we're going to try to solve for x in the equation x to the 4th plus 9 equals 10x squared. So you'll see underneath step 1, I copied that problem down. X to the 4th plus 9 equals 10x squared. And the trick here, I always work very hard to keep my degree holding term positive. Now what does that mean? The thing that has the highest exponent, keep it positive. In chapter 4, we always kept the x squared positive. It made it a lot easier to factor, use the quadratic formula, so on and so forth. However, in this section, I don't want to keep the x squared positive because that's not the degree holding term. So in this case, I'm going to go ahead and subtract 10x squared from both sides. So here's how that looks. Maybe. There we go. So I'm going to subtract 10x squared from both sides. And you're going to see I have one side equal to 0. Now, subtracting 10x squared from both sides isn't quite enough. Because when we factor, please keep in mind that the equation is written in standard form. So in this case, not only did I subtract 10x squared from both sides, but I did another step. Do you see that? I put the equation in standard form. So the equation I'm now going to solve is x to the 4th minus 10x squared plus 9 equals 0. And I need to solve that equation for x. The method I'm going to use to solve for x in that equation is factoring. And I really like my shortcut, my unfoiling, so I'm going to use that. And I have to ask myself, what are the factors of positive 9? And I'm going to pose the question to you guys. What are the factors of positive 9 that could possibly add up to negative 10? Well, yes. And we know that when we unfoil, we're trying to populate two binomials. So you'll see here, oh, it was up there. You'll see that I have, in the next step, x squared minus 9 and x squared minus 1, because negative 9 and negative 1 multiply to give you positive 9, but then add to be negative 10 in between. And then the factors of x to the 4th are just x squared and x squared. If I check this, just checking my outers and inners in FOIL, x squared times negative 1 is negative 1x squared. Negative 9 and x squared is negative 9x squared. And then I'm going to go ahead and factor x squared minus 9 and x squared minus 1. Those are both differences of two perfect squares. So x squared minus 9 is going to factor to be x plus 3x minus 3. And x squared minus 1 is going to factor to be x plus 1x minus 1. And this is all equal to 0. Remember, if I'm multiplying 4 things together and they're supposed to equal 0, one of those 4 things, or all of them, should be 0. So you'll see that I set x plus 3 equal to 0, x minus 3 equal to 0, x plus 1 equal to 0, and x minus 1 equal to 0. This is the zero product property. I have to set all 4 of those things equal to 0, and then I end up getting 4 solutions for x. So we have x equals negative 3, x equals 3, x equals negative 1, and x equals 1. Little clue. There's a little theorem you're going to explore in your trig pre-calc class. And I'm going to go ahead and give it a little nod right now. The degree of the polynomial that I factored was 4. Do you see that? Look at how many answers I have. 4. It's not a coincidence. The degree was 4, and I got 4 answers. Now, that theorem says this. The degree is the highest number of answers you can have. So you could have 4 answers, 3 answers, 2 answers, 1 answer, or no answer. However, you can't have 5. So if you feel like you're in this vicious cycle of factoring and you're like, oh my gosh, I feel like I could get 10 solutions for this question. Well, look at the degree. The degree is going to tell you the largest number of solutions, real number solutions, that this problem will have. So that's a little tip. Questions about that? Okay, I would like you to try one. See number 4 right there in the independent practice? Let's make sure you can do this before we go into a word problem. So go ahead and give it a whirl there. In this problem. Good. Okay. What's left over? Good. Okay, then, what'd you do? Or do you want to keep going, or do you want me to pick somebody else? Ah, thanks, Danny. Yep. And the zero product property says that we have to take anything that has an x in it, set that equal to 0, and solve, right? Do you want to keep going? Okay. Yep. 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 So that equals 0. That equals 0. You would add 2 to both sides, so one of your answers is positive 2. One of your answers is negative 2. Okay. And then x squared minus 3, does that factor? No. So how did you get solutions out of that? Well, you would just kind of undo this problem. In other words, you would add 3 to both sides. Yeah, and then you got a square root, and I heard it. Was that Eric or Joshua? Joshua, yeah, good. Plus or minus the square root of 3, very good. So those are your 5 answers. Degree 5, 5 solutions. So we have 0, 2, negative 2, positive root 3, and negative root 3. Yes. Highest exponent. Degree is defined as the highest exponent in a polynomial. Degree is going to be really important to identify after we come back from the break. Ultimately, it affects the shape of our graph, not just how many solutions we're going to have. So you got to be able to pick it out. Biggest exponent. Okay, we have a word problem. We'll read it together. They kind of give us our variable in this problem. I am going to follow our general step-by-step approach. Assign your variable, write a verbal model, and then write an equation and solve it. So here we have a city park problem, and you are designing a marble basin that will hold a fountain for a city park. The basin sides and bottom should be 1 foot thick. Its outer length should be twice its outer width and outer height. What should the outer dimensions of the basin be if it is to hold inside of it 36 cubic feet of water? Step 1, label your variable. So in this case, they use x. But what does x represent? Good, well, yeah, sure, the outer height. I think you could even say the outer width, right? So we're going to let x equal, you said outer height, right? It kind of follows, I wanted to erase that. No peeking. You don't see this. It kind of follows that x is going to be also our outer width. And then what's this 2x business? The outer length. There will be one like this on your test. You're going to groan in a little bit about that because these are a little bit long. But there is one of them on your exam, a basin problem. And it doesn't tell you what to assign your variables. So you're going to have like length, width, height, and then you're going to have to assign variables to that. Okay, so after you, after you've declared your variables or assigned your variables, we write a verbal model. Well, a verbal model is just basically the volume of a rectangular prism, volume of a box. How do I know that? See this right here? 36 cubic feet of water. Cubic feet, cubic inches, cubic yards, whatever. That's a measure of volume. So I have the formula for the volume of a box. Length times width times height. Now you start filling in for what you know so that you can solve for what you don't. What's V? Yes, and in this problem it is 36. Very good. Now, let's keep in mind, people, there are walls to this basin and a bottom. Oh, yeah, so that we can contain the water. If we didn't have walls or a bottom, I wouldn't be able to fit the 36 cubic feet of water in the basin. I have a tip. We have to write an equation that models the volume of water in the basin. So my tip, pretend you're standing inside this basin. Pretend you're standing in the box or sitting in it. I don't know that it's that deep that you would stand. Pretend that you're standing inside this box. And what I want you to think about is that there are walls around you and a floor that you're standing on. As you're looking through this box you're standing in, is there a lid? No. So there's no like 1 foot of, whatever concrete or anything above you. There's no lid. So you have walls on either side. It does say that each wall is a foot thick. So we need to modify our original length, width, and height. So I'll do the length. You folks are going to help me with the width and the height, okay? So if I want to look at this new length, see here I'm tracing out the 2x. If I'm standing inside the box, the length on the inside of the box isn't 2x. If I'm standing in the box and I'm looking outside, I see it's 2x. But inside where I'm standing, I have to take a foot away from my left and a foot away from my right. That makes it 2x minus a foot on my right side minus a foot on my left side. In other words, this will be 2x take away 2 feet. You follow? You see where that minus 2 came from? Some of you are going to have trouble with that part on the test. These are very similar to the border problems. Do you remember? It was like a border of uniform width, so you had to remember to add it to the left and to the right, and that's where some of you had trouble. So it comes up again. Okay, so I need some help with the width. Ryan. Very good. Now, where'd the -2 come from, Ryan? Very good. 2 sides and they're a foot apiece, so you had to take away 2 feet. Tricky. No lid. What's the new height? Ooh, Joshua. X -1 this time. Why? There's no lid. But there has to be a bottom, or else the water's just going to go right through, right? It's just going to seep right into the ground. So we had to have a 1-foot bottom. Questions about how I wrote that? So I wrote the new length, the new width, and the new height in my equation. Okay, now I'm going to turn the problem over to you. This is where it's independent practice. You have to solve this equation for x. So remember, we're going to follow the 3 steps that are written above us. Step 1, you're going to get one side equal to 0. Step 2, you're going to have to FOIL these and distribute to factor and solve for x. Now, you could get one side equal to 0 right off the bat, or, you do have an option. You can multiply these 3 binomials together first and then subtract 36. Either way, you have to get one side equal to 0. So I'm going to go ahead and let you try this one. Remember, we're trying to find ultimately the outer dimensions of the basin. So when you get your answer for x, you have to tell me, well, how long, how wide, and how tall is this thing, okay? I'll give you a, so just take a minute right now, make sure you have the right problem down so that you can factor it correctly. After you get one side equal to 0, here's what your equation should look like. It should say 0 equals 2x to the third minus 8x squared plus 10x minus 40. Step 1 in any good factoring problem is to do what? God will. Yeah, and I do see one in here. So make sure you take out that GCF before you keep factoring. So I did. I FOILed, I distributed, I got one side equal to 0. Now we start factoring and solving, okay? Putting this for the people at home. When you factor it, you get 2x minus 4x squared plus 5. And I used grouping. And it looks like most of you did too, so good job. And then I went ahead and solved for x. I added 4 to both sides and got an x value of 4 feet. And then I did get an imaginary solution for the other one. You can't have that. So your final height and width are both 4 feet. Final length is 8 feet. You have to finish 5-4 practice B for homework. You grabbed an answer key when you walked in. Make sure you check yourself. Tomorrow and Thursday are review days. So nothing new until, we come back from the break. You're done with your new material for the year 2013. Yes!